coming. It's not physical coming, right? It's just opening the browser. I'll be talking about virtual tracks. I'll be talking about Jakarta EE. And when I'll be talking about virtual tracks, I'll be actually talking about the Helidon. But first, I will introduce myself a little. I am Daniel Katz. I work at Oracle as a Java developer, and I'm a team member of the people who are making the Helidon. You can find me on those various social networks, the old ones like Twitter, or the new ones like the Blue Sky and Mastodon and all the others. You can read my blog articles at Medium and ask me any Helidon-related questions if you want. We have a really short agenda because this will be a very short slide deck. So we will do just two things, actually. We will introduce Helidon, what is it, and what features it has. And because that is actually a first full-blown virtual thread-based web server on the market. And then we will move to the Jakarta EE compatibility, and we will see how Helidon is first runtime actually certified, first Jakarta EE Core runtime actually certified, and on top of the virtual threads. So we will take a look what has changed there. So what is the Helidon and what is it good for? Helidon is a microservice framework. To explain it best, our main competitor is a Spring Boot. It's very similar. It's a web server built to play nice with Kubernetes from ground up. It's completely open source, even though it's backed by Oracle. All source code is available at GitHub. You can find it, you can contribute, you can file an issue if you find any. And unlike Spring Boot, Helidon keeps the number of third-party dependencies as low as possible. This is very important for a lot of our enterprisey users. Because if you ever worked in enterprise, you know how hard it is to get approval for that another third-party library you just need, or a couple of them you need because of the new framework you are using. So Helidon keeps the number of third-party libraries as low as possible. So if you are making the small Hello World application, you don't actually have to download the half of the universe with Helidon. It will be really, really small. And with Helidon, you can choose your path with the right flavor. We have two flavors of Helidon. We have Helidon SE, which is a micro framework. There is no magic, no injection. It's a pure performance, which you have to wire yourself together with builders and Lambda. So if you want to make your hand a little dirty, you can do everything yourself and you have full control about everything. If you want to go a little more enterprisey and use annotations and injections, you can use Helidon MP, which is completely annotation driven. It implements microprofile specification, so you have many Jakarta specs implemented there, like the RESTful JAXA-REST, the CDI. So you can use annotations and inject stuff instead of wiring everything yourself and concentrate more on your business agenda. It's very easy to use then. Helidon MP actually uses Helidon SE under the hood. So this powerful engine of Helidon SE built on top of the virtual threads is actually powering Helidon MP. MP is just adding all kinds of magic so you can concentrate at your business code fully. Here is HTTP get hello world resource in both flavors, so you can compare it. I say resource, the Spring developer would say controller, right? On the left side, you can see Helidon SE builder pattern with Lambda, and on the right, you can see JAXA-REST resource with annotations. That's very same JAXA-REST resource you would use in WebLogic or Glassfish. or Tomcat if you wouldn't be using the servlet. So this is very familiar API for any enterprise developer out there. So this is the distinction. With Helidon SE, you are actually want to tweak it to get the best performance possible and do everything yourself. With Helidon MP, you want to do, the work done. So what is new in Helidon 4? Helidon 4 is fairly new. It requires JDK 21 and newer. It's simply because it's built from top on the virtual threads, from the socket all the way up to your Jaxares resource. Everything is virtual threads. There is nothing reactive, nothing asynchronous there. And you achieve the comparable performance like with the reactive APIs. So we got rid of all the reactive stuff from our web server. We got rid of Netty, well-known and very powerful library for working reactively or asynchronously with sockets in Java. Yet we are achieving comparable performance. It's simply because it's the same trick behind the hoods. We are just avoiding the context switches, same way like you would with reactive APIs. But this time you don't have to have the reactive APIs. It's all nicely hidden from you, and you can use really simple imperative code, which is easy to debug, easy to understand, and easy to explain to that junior developer who just joined your company, right? So we have created a brand new web server for this, the one which is fine-tuned for the virtual threads from the socket all the way up. There is no reactive layer anymore. And when we say that we are using virtual threads, there is no offloading or retrofitting. We are not using, the old stuff and just running, starting new virtual threads on top of it. We have started right from the sockets. So we have been actually the first implementation who used virtual threads in this way. The Helidon is virtual thread per request in a web server built specifically to work best with virtual threads. Also, we are optimized for Java sockets with virtual threads. We get faster and faster each time new release of Java arrives. So with Helidon, you get more performance for free each time Ron Pressler and the other guys from the Loom team makes the JDK a little more faster. That's because we have been developing Helidon with close cooperation with JDK team. Removal of Netty allowed us to get rid of all the reactive APIs. Again, this is very important. That's why I'm repeating it so many times. Our brand new web server with the secret code name Nima is clean, fast, and optimized for virtual threads from ground up. Helidon SE API, which was reactive before, and reactive APIs are kind of viral. They are just, going through all your code base, and once you infect your code base with it, you cannot get rid of it. That changed significantly because it was replaced by the API which embraces the blocking code, the imperative programming. Way easier, big change there. In Helidon MP, in the more enterprisey version, nothing has really changed because it has been always imperative. It was always been blocking. It had to be simple with all the injection. So nothing has changed there. It just got way faster. So Jakarta RESTful APIs didn't change at all. We do provide 3 ways of packaging of Helidon application out of the box. The default one is a tin jar. It's a small application jar just with your business logic, accompanied by lib folder for all the dependencies, even the Helidon ones. Everything is all dependencies are in the lib folder. If you have ever programmed in C-lang, it's very similar deployment model. And this is very practical for Docker image layering. So if you do some small change in your business code, you don't have to really push all your dependencies into that remote Docker repository. You will push just the layer with your business code and with a few bytes you have changed. Another option is J-Link image. We have in our quick starts, we have prepared Docker images with that packaging option already. It allows creating minimalistic custom-tailored Java runtime just for your application. It understands JPMS modules and it does a tree shaking of your JDK so you can keep only the parts which you really need. By the way, all Helidon modules are JPMS module, like the proper ones, because we are Oracle shop, so we have to do everything properly, right? I did this small example for you with our quick start Hello World, and I have achieved a 74% size reduction with JLink image. My example was 340 megs. That was the JDK plus the application. And I created an image of 88.5 megabytes. So it was really small, and out of that 88 megs, 23 megabytes was actually a context data sharing archive, which you may know now from the Helidon project. That's the way how you can actually warm up in advance your application and save some build time startup data, so you can start really fast and with peak performance already. And the next one is Graal VM native image. You can create native binary with super fast startup time with Helidon. We have been supporting this for years now with both flavors, with SE and MP. So all your CDI and JAX-RS annotation-driven applications will work just fine with native image. It has more advanced reshaking, which does not depend on the GPMS modules. So with my small Hello World example, I have achieved 88% size reduction. For example, that example of 340 megs, I have managed to lower to 41 megabytes. And again, like with the JLink, you don't need any additional JDK in your Docker container anymore. It will just run as it is because JDK is already there. All those options are easy to use with containers. That's what we are trying to help you with. Helidon also supports ahead of time optimization for faster startups and immediate peak performance. Again, we have extensive native image support, and thanks to that, you can get up to 40 times faster startup. That's what I have measured with my small example with the PGO. That means you create one native image, you do the training and warm up, and then you create another one, and then you get a really fast binary which starts immediately and super fast. Helidon also works great with Helidon. Cool thing about Helidon is that there is no extra effort needed from your application, and you get almost 3 times faster startup for free. You can do warm-up training to reach peak performance right after the start and everything, and you don't have to really change anything. It works out of the box with any Java application. And we have just added support for crack. That's not a drag or something. That's coordinated restore and checkpoint technology. It's based on the CREW. If you use Linux, you know it. Every time you make your computer sleep, that's what's used behind the scenes. And that's also a very cool way for achieving more than 30 times faster startups with Helidon. That's what I was able to measure with my really small example. And some AI, we have to add it, right? I guess I can safely say that LangChain4j is the most popular library for using LLMs in Java right now. It is inspired by LangChain Python library. It brings ton of cool features abstracted away under a very nice API. And with LangChain4j, you can wire together LLMs, vector stores, tools, and more, and you switch underlying vendor libraries with ease. The strength of the library is the lean abstraction its API provides. So can we make the LangChain4j API even better? Well, we surely try in Helidon, and you can use our integration for LangChain4j, which is built on top of a brand new feature, the Helidon Inject, which is a completely built time. So it has injection which have no impact on performance. Everything is done in the build time. This way, you can have all those annotations you are used to with LangChain4j in Helidon, and it will be super fast. And you can use it in both flavors, in Helidon SE and Helidon MP. So you can use it from CDI beans, JAX-RS resources, or from Helidon SE Builder Lambda. So you can use it everywhere in Helidon. And of course, Helidon integrates well with WebLogic, right? We are from Oracle, so we have certified integration with WebLogic. You can integrate over JMS, REST, good old-fashioned SOAP, single sign-on over OpenID Connect, or you can use distributed transactions with LRA and XA together with Oracle MikroTX Transaction Coordinator. All works nicely together. So that is Helidon, our virtual thread-based microservice framework. Uh, um, Now we can jump into the Jakarta compatibility now. That's what we will be talking about. You may have already heard the big news. The Helidon 4 is certified as Jakarta EE Core compatible runtime. But that doesn't mean that Helidon is some kind of a newbie within Jakarta EE ecosystem. Yes, previous versions were not certified as Jakarta compliant, but as you can see in this little timeline I have prepared for you, since the release of Helidon 1 at the beginning of 2019, the Helidon MP implemented all the necessary specifications under microprofile umbrella, including Java EE in Helidon 1 and later Jakarta EE APIs in Helidon 2 and 3. Unluckily, until recently, there was no direct intersection between the Jakarta EE specifications we considered as practical for microservice development and certifiable Jakarta profile. So there was no profile no Jakarta box which would actually fit all our needs. So we haven't been really certified, but we have been implementing a lot of Jakarta specifications. Because Helidon was always a standard-based microservice runtime. And that's no random coincidence. The Helidon core team in Oracle actually consists of many seasoned committers to various Jakarta EE implementations and specs. Just to list some, I can name Toplink for JPA, Eclipse Link, again, JPA, Moxie, JAX-B, Jersey for JAX-RS, Yasen, Metro, JSON-BRI, Parson, Tyrus, HK2. There is a lot of them. There's a lot of my teammates are actually actively committing or even spec leading some of those specifications. That's why the Helidon has been always the big brother of all those specifications. With Helidon 4 MP and Jakarta EE 10, Helidon fully covers all the specs that are practical for microservice development. Plus, it partially covers others for the very same reason. So as you can see, we didn't really need it servlet and server pages and enterprise bean. We don't need it AGBs in microservices, right? That's why even the Jakarta web profile was still too wide for us. But we would have all the goodies we needed, yet not be able to claim the true Jakarta compliance. But the Jakarta 10, a new, slimmer, and for microservice development, more practical profile came, the core profile. Jakarta profile specifically created for the bare minimum needed for microservice development. So as you can see from already smaller web profile, which was still too wide for us, too big box to fit in, just a few essential specs were cut out as a Jakarta EE 10 core profile. Profile tailored specifically for microservice development. You can notice that CDI has been split to CDI and CDI Lite, more build time friendly subset of CDI specs. And another ones which are really necessary, like the JAX-RS for the RESTful web services, JSON support, dependency injection, and so on. And microprofile 6 took it on pretty fast and moved from dependency on the several Jakarta EE specs, which was quite messy, to a single Jakarta EE core profile, therefore aligning with Jakarta really nicely. And this is simplifying the situation to all the runtimes and libraries for microservice development, not only for Helidon. Situation is much more understandable for our users, and the relationship between Jakarta EE and microprofile is clear. Again, we can compare how Helidon 3 implemented several standalone Jakarta EE specs to be microprofile 5 compliant. This is the situation before. This was a little complicated to grasp and explain. So I have created those small icons, if you can see them there. There is Jakarta for the Jakarta specs, this sailboat, and there is microprofile logo for all the specs which are part of the microprofile. So the microprofile has always been based on top of the Jakarta specs, on the selected ones, not any special profile. It was micro profile. And even the creation of this slide took extra effort because it was hard to figure out which one is one, right? While with Helidon 4, we do the same thing. We are just supporting same specs as we did, just the new versions of them. And with Jakarta EE 10 Core Profile, we are fully compatible now. And you can see that small box on which the microprofile 6 now depends on is actually kind of like a placeholder for all those specs which were messy to understand. The situation with microprofile in Jakarta EE is very obvious now. Jakarta EE Core Profile is making a base platform for other microprofile specs. It's easy to understand and is very easy to explain. It is still very similar to previous situation. As you can see, we are just implementing newer versions of all those separate Jakarta specs. But the relationship is clearly defined. You can see that microprofile depends on the core profile, and the core profile clearly defines which specifications from the Jakarta actually belongs to there. And because of that, we can proudly say that we are Jakarta EE compatible runtime. Finally, we have been always, but this time there is a right box for us, right box for the microservices. Because of the new Jakarta EE 10 Core Profile and Microprofile 6 alignment with Jakarta EE 10, the whole concept gets way simpler to understand for our users. And that is not something that comes really cheap. It's an assurance for our users that their Helidon MP-based application won't be bound by a vendor lock. It will be easy to maintain and upgradable to new versions of Helidon. And if someone doubts that, we can simply send them to check that Helidon is actually listed as Jakarta EE Core compatible runtime on the Jakarta EE web pages, right? There is a box for us, finally. Our users have clear assurances, not only from us, but from the whole great Jakarta EE community, that their business code won't get old too fast as it could in any vendor-locked runtime, as their developers don't have to be a single runtime specialists. And support for the APIs they are using will be much wider than it could ever be from any single vendor right now. And that's all for the Jakarta running on virtual threads. If you want to know more about Helidon, you can find out about us on our web pages. We have really nice ones. We have a Twitter account, Blue Sky account, Mastodon account, all the accounts. We are blogging a lot on the Medium, so you can read some interesting articles on our Medium channel. Is it channel? We are completely open source. You can find all the source codes of Helidon on GitHub. We are even doing some videos on YouTube, not much recently, and we have also a public Slack channel for free support. So if you have any technical problem with Helidon, you can contact us there. There is always some developer assigned to that channel for a given week. So we are trying to have always professionals looking over that channel and helping our users.
Wow, always on support. That sounds nice, being a developer. We also have a question from the chat. Hi, Daniel. Okay. Who do we talk to integrate CDI synthetic bean to Helidon fault tolerance, like command binding annotation?
It's Tim. You can find Tim Quinn. He can help you with fault tolerance, or Tomas Langer. Those are the guys that know most about the fault tolerance for CDI. Yeah. We are implementing the microprofile fault tolerance spec, so everything should work as it is. If not, that would be an issue. And I don't really know the command binding annotation. Sorry for that. I'm not expert in that area.
And you said you have the Slack channel you already provided where we can find it. Okay, great. And can you help me a bit? I think I got a bit confused by the title. So you had virtual threads, but it's like Helidon running on virtual threads, or is it just the best place for me to run virtual threads in Java?
It's the best use case for virtual threads, because if you use virtual threads from the ground up, for the sockets, you actually, with virtual threads, you are actually replacing the need for the whole Netty library, which is really cool library, which has been for years the best way how to do networking with Java really fast. But now we don't really need it, because all that really complicated trick for avoiding the context switches when the sockets are blocking is actually done behind the scenes. It's the same trick. It's just done the way that you don't have to pollute your code base with all those reactive APIs. And once you get into the reactive APIs, it's really hard to clean it up from your code base. And because we have been using reactive APIs in Helidon for years, we know that almost no one is doing them correctly. Your code base gets that complicated that all that performance benefits are just lost in all the mistakes you do when you block somewhere when you shouldn't, or you don't use flat map as you should, and stuff like that. It's always very complicated. Even the senior developers have problem when they're returning to some older code base to understand what they have been actually trying to do there. When you are debugging stuff, you are jumping, from one place to another. The stack traces doesn't make sense anymore, and it's really complicated. So with virtual threads, everything gets super easy. You can explain it to anyone. It's imperative. It's blocking, and the performance is on par with reactive streams.
Yeah, and I don't have to decide upfront that I want to use them. I can code my code like I did before, and just by annotations or configuration, I can use them.
You can use some old libraries which are written for the physical threads, and it will work just fine.
True, true. Okay, thanks for enlightening us with Helidon. Do you want to say anything about, to compare Micronaut and Helidon?
Compare Micronaut and Helidon? Well, Micronaut is using Netty, so that's the problem. They're offloading to, if you want to go with virtual threads in Micronaut, I'm not sure what the support is right now, but what I'm pretty sure that they are using Netty behind the scenes. Mm-hmm. So if you are using reactive web server, you have to offload to the virtual thread. That meaning that you have to start new virtual thread and let loose the worker threads from the Netty. And this is just, another layer of abstraction. You are still keeping this super complicated nuclear power plant behind the scenes, and that's really not necessary anymore. You can make it very simple. That's what we have really learned from rewriting everything to virtual threads, is that our web server is that simple. If we have some issue, we can fix it really easily because everything is super small, super easy to reason about. While if you have ever worked with Netty APIs, you know that it's not easy thing to do.
Okay. Thanks, Daniel, for being with us. It was very helpful, and I learned a lot of things about Helidon, and also I love the fact that you're now Jakarta EE compliant. So we have that, something to celebrate. And